Today we're going to explore geometric sequence. We will find the indicated nth term of a given geometric sequence. Each term in a geometric sequence is the product of the previous term and the common ratio r. In the sequence 3, 6, 12, 24, the first term is 3, second term is 6, third term is 12, and 24 is our fourth term. To find the next term, we multiply the previous term by the common ratio, in this case, r is equal to 2. The nth term of a geometric sequence is given by the formula a sub n is equal to a sub 1 times r to the power of n minus 1. And a sub n is the nth term of the sequence, a sub 1 is the first term, r is the common ratio, and n is the number of terms. Here are the 5 examples of a geometric sequence. Find the common ratio and the indicated term of each geometric sequence. Give it a try and play the video whenever you're ready for the solutions. Question number 1. Find the common ratio and the 10th term of the geometric sequence 3, 9, 27, 81, and so on. In solving for the nth term, we need 3 things. We need the common ratio r, the first term, and the value of n. What do you think is the pattern in this sequence? The pattern here is multiplying the previous term by 3 to get the next term. 3 times 3 is 9, 9 times 3, 27, 27 times 3 is 81. Another way of solving for the pattern or the ratio is you can divide the second term by the first term. That is 9 divided by 3, which is of course 3. Or you can also do 27 over 9 and 81 over 27. All of this will give a constant quotient of 3. So the common ratio for this geometric sequence is 3. A sub 1 is the first term, which is also 3. And since you were asked to find the 10th term, that means our n value here is 10. In solving for the nth term of a geometric sequence, we will be using the geometric sequence formula a sub n is equal to a sub 1 times r to the power of n minus 1. In this problem, our n is 10, so we are solving for a sub 10. Our a sub 1 is 3 times our ratio is 3 to the power of 10 minus 1, and that is now 9. Using your calculator, you need to evaluate 3 to the power of 9, and then you multiply by 3, which is 59,049. That is our 10th term. Question number 2. Find the common ratio and the 12th term of the geometric sequence 2, -4, 8, -16. So the same thing, we need to find first the r or the common ratio, the first term, and the value of n. What do you think is the pattern for this sequence? The pattern for this sequence is multiplying the previous term by -2. 2 times -2 is -4, -4 times -2 is 8, 8 times -2 is -16. So the value of r, or the common ratio, is -2. Another way of solving for r is dividing -4 by 2, dividing 8 by -4, or dividing -16 by 8. All of this will give a common ratio of -2. Our first term is +2, and we're solving for the 12th term. That means our n is 12. So now we will be using the geometric sequence formula a sub n is equal to a sub 1 times r to the power of n minus 1. We're solving for the 12th term, so that is a sub 12. Our a sub 1 is 2 times our r is -2 to the power of 12 minus 1, and that is 11. Now let's evaluate this using your calculator. -2 to the power of 11 multiplied by +2. So the answer is -4096. That is the 12th term of this geometric sequence. Question number 3. Find the common ratio and the 14th term of the geometric sequence 64, 16, 4, and 1. The same thing, we need to find first the r, or the common ratio, the first term, and the value for n. What do you think is the pattern for this geometric sequence? The pattern is multiplying the previous term by 1/4, or that's the same thing as dividing by 4. So the common ratio here is not 4, but the common ratio here is 1/4. And you can do that by dividing 16 over 64, 4 over 16, or 1 over 4. All of this will give us a common ratio of 1/4. Our first term is 64, and n is 14 because we were asked to find the 14th terms. The value of n is 14 since we were asked to find the 14th term. Now we will use the geometric sequence formula. A sub n is equal to a sub 1 times r to the power of n minus 1. We're solving for the 14th term, so that is a sub 14. A sub 1 is 64 times r is 1/4 to the power of 14 minus 1, and that is 13. Using your calculator, we're going to evaluate this, and this is 64 times 1 over 67,108,864. Simplifying this further, we have 64 over the denominator. In simplest fraction, we have 1 over 1,048,576. That is the 14th term of this geometric sequence. Question number 4. Find the common ratio and the 15th term of this sequence 0.2, 1, 5, 25, and so on. We need to find 3 things beginning with the common ratio r, the first term, and the value of n. What do you think is the common ratio here? Common ratio here is 5 because the pattern is multiplying the previous term by 5 to get the next term. Or you can do 25 divided by 5, 5 divided by 1, or 1 divided by 0.2. So that is a common ratio of 5. Our first term, or a sub 1, is 0.2. We were asked to find the 15th term, so n is 15. Now using the geometric sequence formula, a sub n is equal to a sub 1 times r to the n minus 1, we can now solve for the a sub 15 because n is 15. A sub 1 is 0.2 times the common ratio 5 to the power of 15 minus 1, and that is 14. Using your calculator, let's evaluate first 5 to the power of 14 and then multiply it by 0.2. So we will have 1,220,703,125. That is the 15th term of this geometric sequence. Question number 5. Find the common ratio in the 16th term of the sequence 3/8, 3/4, 3/2, and 3. So for this problem, we also need to find the value of r, our a sub 1, and n. What do you think is the pattern for this problem? The pattern for this problem is multiplying the previous term by 2 to find the next term. If you're not sure, one way to do this is you can divide 3 over 4 by 3 over 8. Or you can divide 3 over 2 by 3 over 4. You can also divide 3 by 3 over 2, which is easier. So simplifying this, we will have keep, change, flip. We keep the 3/4. We change the division to times. We flip it. That's 8 over 3. Simplifying this, 3 divided by 3 is 1. 8 divided by 4 is 2. So the common ratio here is indeed 2. Our first term is 3/8. We were asked to find the 16th term. So our n value here is 16. Now we will use the geometric sequence formula a sub n is equal to a sub 1 times r to the power of n minus 1. We are solving for the 16th term, so that is a sub 16. Our a sub 1 is 3/8. Common ratio is 2 to the power of 16 minus 1, so that is 15. Using your calculator, let's evaluate this. So we have 3/8 times 2 to the 15th is 32,768. Simplifying this further, we multiply 3/8 by 32,768. The answer is 12,288. So this is the 16th term of this geometric sequence. So again, in solving for the nth term of a geometric sequence, you need to find three things. You need to have the common ratio r, the first term a sub 1, and the value of n. Once you have this information, all you need to do is plug it into the formula a sub n is equal to a sub 1 times r to the power of n minus 1, and then evaluate the sequence. Thank you for watching, and please consider subscribing to my channel at Celzo Academy.